Okay, 1-5 notes 2, compound inequalities. And if you think about what the word compound actually means, compound means 2. Okay, so what we're talking about here is 2 inequalities. When you have 2 inequalities, you can have 2 types of solution. Okay, you can have you have a number line. You have a number line, and if I have 2 inequalities, one inequality can be going this way, right? And the other one can be going this way, and what happens is they bounce back and forth between each other where both this condition and this condition have to be true. Okay? When you have an or inequality, or 2 inequalities that have one or the other one is true, you have one inequality goes this way and one inequality goes this way. Okay, that means one condition or the other condition is true, not both. So let's keep going here. Okay, so when we have these 2 inequalities, we know we have 2 compound inequality, means 2 inequalities, and the word or is here, so we know that we have a condition where one goes one way and the other one goes the other way. One is true or the other inequality is true, not both. So let's go ahead and solve these like we would as 2 separate inequalities. So I'm going to go ahead, if you look, this is one of them here, and then one is over here. So I'm going to add x to both sides here, and I'm left with 3x is greater than 3, and divide by 3, so I have x is greater than 1. Or, and make sure you put the word or in there, if you don't, it's actually wrong. Or, now we solve the other one. We'll subtract x, because remember, compound inequality means 2 inequalities. So I have 2x minus x is just x is less than -3. So those are my 2 conditions. And I know that one or the other has to be true, so they have to be going in opposite directions of each other, because if they're going the same way, that means both conditions are true. So that means I have to, when I graph it, I'm putting 2 numbers on the line, and make sure you put them in the right order. Some students like to put -3 on this side and 1 on this side. No, on an actual number line, okay, 1 is on this side to the right and -3 is to the left. For this condition, it's an or and it's an open dot because my 1 is right here and it's going this way. On this side, this one is also an open dot and it's going this way if you look at the arrows. So that is what an or inequality looks like. When I say or inequality, that means 2 inequalities where one or the other one is true. Let's go ahead and solve this one. We have 2 inequalities with an or. That means we have 2 going in opposite directions. I'm going to subtract 7. So I have 2y is greater than 6. Divide by 2. I have y is greater than 3. Or plus 2. So I have -3y is greater than or equal to 12. Divide by -3. Don't forget, when you divide an inequality by a negative number, you must flip the sign. That is always true. So I have y is less than or equal to -4. Or y is greater than 3. So when I put these on there, -4, this one's already here for me, 3. 3 has an open dot, so it's going this way. 4 has a closed dot because of the equal to underneath the inequality symbol, and we're going this way. So all the x is greater than 3, or I'm sorry, all the y's are greater than 3, or they are less than 4. So if I asked you, does -3 work? You would say no, because -3 is right here, and it does not fall within those one or the other. So -3 would not work. All right, let's solve this one. I'm going to multiply both sides by -5. And don't forget, when you multiply both sides of an inequality or divide by a negative number, you have to flip the sign. So this becomes greater than or equal to 3x is greater than or equal to -30. Divide by 3. So x is greater than or equal to -10. For this one, I have to get rid of my addition subtraction first. So I'm going to add 1. So I have 1/5 x is less than or equal to -3. Now, here's something you might not remember, so I'll refresh your memory. In order to get rid of a fraction, you can multiply by the reciprocal, okay? Multiplying by 1/5 is the same as dividing by 5, so we're just going to multiply both sides by 5. 1/5 times 5 is 1, which is exactly what we want. So x is less than or equal to negative 15. So that's my final answer. X is less or greater than or equal to negative 10, or x is less than or equal to negative 15. To graph that, I have negative 15 over here. Negative 15 is actually less than negative 10. Here my x is going to be a closed dot, and the arrow is going this way. And on this side, x is going to be a closed dot, and my arrow is going this way. Okay, continuing on. There's nobody in here, I'll go ahead and take that off. All right, and compound inequality. This is the other kind of inequality that we talked about where the two conditions run into each other. That means both inequalities are true. That's why we say and, because they're both true. Me and you means both of us. So if we solve this one, solve the first one, I divide by negative 6, divide by negative 6. Don't forget when we divide by a negative, you have to flip the sign, so that becomes greater than or equal to. So I have a is greater than or equal to negative 3. On this side, I have to solve for a, so I'm going to get rid of 5 first, subtract 5. So I have negative 3a is greater than negative 3. Divide by negative 3. We're dividing by a negative, so flip the sign. Oh, positive 1. Now, my final answer, a is greater than or equal to negative 3, and a is less than 1. Okay, so if I were to go to graph that, I would have 1 would be here, and negative 3 is over here. On negative 3, we have a closed dot. 1 has an open dot. And then this one goes this way, but this one goes this way. So they run into each other, meaning both conditions have to be true, meaning it's everything in between those two. Okay, so if you look at this, this is what an and graph looks like, and this is what an or graph looks like. Opposite directions, together. All right, let's solve another and. Now, when you have something that looks like this, that has two inequalities and something stuck in the middle, this is always an and, okay? This just means that they took the two inequalities and kind of pushed them together. So you can solve this all at one time, okay? So pay attention here because this is different than what you've probably done in the past. If I subtract 11 from the middle to get x by itself, I have to subtract 11 from this inequality, and I have to subtract 11 from this inequality. Okay, you have to do it to both inequalities. Remember, compound inequality means 2. So I have negative 12 is less than negative 6x, which is less than negative 10. Now, in order to get x by itself, my x is still stuck in there. In order to get it by itself, I'm going to divide by negative 6. Whoops. Divide by negative 6. Now, when we divide by a negative, we have to flip the inequality symbol. So we're going to make this one greater, make this one greater, and I'm just going to simplify these. This one gives me positive 2. This cancels. And negative 10, 6, if I reduce that, it's going to be positive divided by 2 is 5, divided by 2 is 3. Negative divided by negative gives me a positive. Now this is going in the wrong direction, so I want to rewrite it so that my smaller number is over here. So I have 5/3 is less than x, which is less than 2. And the reason we do that, it will never be written like this on like an ACT test or a standardized test. They're always going to put it in the right order. The smaller one over here, the larger one over here. So let's go ahead and graph this. When you graph this, it's kind of nice when you have an and. We know, because it's an and, we know they're going to hit each other. So 2 is going to be over here. 5/3 is going to be over here. Open dot on both. And since it's an and, that means we are filling in the middle. All right, next one. This is also an and, except it's not written together, so we just solve them both separately. So I'm going to add 2. So I have negative 4x is greater than or equal to 12. Now I'm going to go ahead and divide both sides by negative 4. And since it's a negative, I'm going to flip the sign. So I have x is less than or equal to negative 3. And this side, solving for x, I'm going to subtract 1 first. So I have negative x is less than negative 1. Divide by negative 1, and since we're dividing by a negative, we flip the sign. So I have x is greater than 1. Make sure you put the word and in there. That's how we know if the difference between the two answers, if it's an and or an or. Now, you might have this answer on when you complete the problem, and you're right. But you look at your Math Excel or you look at your quiz, and it's not one of the options to pick. So you have to be able to switch this and make it look like this sometimes. So if I do that, I'm going to put the smaller number over here, put the x in the middle, and then I'm going to put the larger one over here and share that sign. So this right here, if you look, is that, and this is that written backwards. Okay, so that's what that looks like. Now if I go to graph it, I have 1 on this side, negative 3 on this side. I'm going to have an open dot on the 1, closed dot on the 3, and it's an and, so I'm filling in the middle. All right, we'll do one more. This one, I'm going to add 5 to this inequality, and add 5 to this inequality. Remember, it's two inequalities. So we have k is less than 5, which is less than 4. So we're between 5 and 4. Here's 4, here's 5, open dot, fill in the middle. Okay, so compound inequalities means two inequalities. They can either go in opposite directions or they have to hit each other. Okay, those are the only two types of and or, only two types of compound inequalities we're going to have.